The other type of input page is the input page for the two-branch connection. So here you can see that looks quite similar to that input page for the one-branch connection, except of course there are two branches now, and also the branches don't have the option to specify an in-plane or out-of-plane bending moment on them. At the bottom, there are also some inputs for K connections, such as the gap and the eccentricity. You can say whether the hidden toe should be welded or not, and also you can specify the overlapped order when applicable. You also have the option to choose the magnitude of units. So you can choose between newtons and kilonewtons and millimeters and meters, and this feature is also available on the one-branch connection input page. We go back to the home page and you change to using US customary units. You can now see that the units you choose between are kibs and pound-force and feet and inches. So now I'm going to quickly set up a K connection example using the left side pin as before. We'll enter some branch forces, some angles using the global angle system, and we'll specify an eccentricity of 0. We can see what we get. So we have an overlapped K connection between two CHS sections. And of course, like before, we can change the menu we use, so we can go to RHS if we want. And now we have a K connection between the two RHS sections. You can see here how the overlap order is program defined. We didn't change that, and here won't make much of a difference. But for instance, if we had an end connection where one branch was at 90 degrees, we might want to make it so that branch 2 overlaps branch 1. And we can see that, oh wait, no, branch 2 is 90 degrees, branch 1 overlaps branch 2. That is my mistake. And now we can see the branch order change. So if that is important in your analysis, you can also toggle that when applicable. We could also make this connection gapped. We went back to using the two 45-degree angles, and let's make the branch sizes a bit more reasonable, make them a bit smaller, and add a gap now. And now we have our gapped K connection. And we can specify this gap here, or of course we could also do an eccentricity if we wanted. It's important to mention that you can also specify an overlapped connection with this gap feature if we change it to a negative. So now that would be a negative 4-inch gap. We'd have to make it a bit larger. There we go. Now we have our overlapped connection by changing the gap. But let's go back to our gapped connection. But it's important to know that you can specify the gap as positive or negative, and that corresponds to either a gapped or overlapped connection. Let's say we had an error where we made a gap which was too small for the limits of applicability, and they're telling us the gap should be greater. If for some reason we wanted to use this gap because maybe it was restricting it because they think that we can't do a feasible fillet weld between these two branches, and we thought that we could, or we were going to do another type of weld, we could still continue the analysis outside the limits of applicability. So if you ever run into an error that you can't get rid of and you know you want to ignore and it is safe to ignore based off some analysis you did external to this program, you can ignore that error, but the error will still appear here, and ideally you operate within the limits of applicability and do not get any errors. You can also see that if we go back to an overlapped connection, if we make one branch thickness smaller than the other, the program will automatically tell us which branch needs to overlap which, and you always need them to overlap. Finally, for a two-branch connection, it doesn't just have to be K connections. You could also have an X connection. This is where it's very useful to have these global angles. So for instance, I could have 90 degrees and negative 90 degrees to make both of these tension. And now we have our X connection with the branches on the opposite side of the cord. And of course, we could change this to a different angle as well. And there we go. Now we have our X connection. We can also use a reaction to make a X connection in this program as well, even with the two branches. So if we go back to our gapped K connection here, and we made the branch forces more imbalanced, so now we have a K and a Y component. If we add a vertical reaction, you can see that we now have an X component to this connection, also balancing some of the punching force from the branch with the larger axial force. So like before, if we name our connection example to two-branch example, we can save that also to our computer and return to that when we need to.